January 26th to simulation.
Looks like it will be normal plan path for you. You're going to have your landmarks, and if we can get you the 2-1 data, we'll let you read it up to them. What data was that, flight 2-1 pad? Okay, we only read if it's no go. We've got TM. That's negative. That's negative. We've transmitted TM on, but we have no TM. Roger. IU TM. IU telemetry. No telemetry, Carnarvon. Capcom booster. Receiving IU data. I got PCM sync IU. Carnarvon, Apollo 1. Okay. Apollo 1, Carnarvon. How's your S-band telemetry, Carnarvon? Any joy there? Apollo 1, Carnarvon, do you copy? All right, we read. Roger. We have no telemetry from the CSM at this time. Roger, our status hasn't changed. We're still going. Roger. Chuck, how's your VHF or S-band, or don't you have either one? That's affirmative, flight. Are you seeing any modulation whatsoever? Okay, we've got data now, flight. Okay.
Carnarvon, AFD, do you have your flight plan update?
Roger.
Okay.
Our battery relay bus is reading.
Carnarvon, Apollo 1, do you have telemetry now?
That's affirmative, Apollo 1. We have telemetry.
Okay,
Battery relay bus is reading. Capcom, we're not reading you. Apollo 1, Carnarvon. Carnarvon. Raj, we're reading very low voltages on your battery relay and main bus A and B. Battery bus A and B. Could you give us readouts of those, please?
Roger, you want bat bus A and B?
Raj?
Okay, bat bus A is reading 37 volts. Bat bus B is reading 37 volts. You were reading low voltage because we had our Mesky logic circuit breakers open, which power that sensor.
Raj?
If you've got a reading now, I'd like to open them again.
Okay, 35 and 36. Okay, we're reading 35 and 36. Relay bus is reading, still reading 2 volts on the ground telemetry.
Okay, we can't read the relay bus voltage director.
Right, Carnarvon, we're reading a battery relay bus voltage of 2 volts. Okay, Chuck, we'll take a look at it. How's main A and main B look? It looks okay. Okay. Go ahead. We have a section shaft drive failure. Repeat, Apollo 1. Sextant drive shaft failure. Roger, the sextant, the optics won't drive in the shaft. We got that, Chuck. Okay, we have you go here on telemetry. I've got a landmark update for you when you're ready to copy. Bye-bye. Roger. Landmark. 013936. Remarks 37. Next item 014012. Remarks 45. Next item 014033. Remarks is 44. Next item 014043. Remarks 43.
37, 014015, 45, 014033, 44, 014043, 43.
Okay, on that second item, the time was 014012.
Roger, 014012 on the second item.
Roger.
We should make planning that those times are too close together for adequate landmark tracking.
Looks that way to me, and there's a note here. These times are at a 30-degree elevation angle.
Roger, understand. 30 degrees elevation.
Roger. We'll get further word on those times to you. I'll check on those. Right, Carnarvon, we're reading 21.6 psi on the battery manifold pressure.
Say again, Chuck.
We're reading 21.6 on battery manifold pressure. Okay, and there's a question about this flight plan update on the landmark times. They're all within 30 seconds.
Roger, Chuck. Jerry Jones is looking at it.
Roger. Did you copy the failure of the sextant drive shaft?
Roger, we copied. Carnarvon, Houston. Carnarvon, Capcom, Houston flight.
Go, Houston.
Roger. Can you advise the crew that you're reading a high battery manifold pressure? And will you have them verify the battery manifold vent valve is open?
Roger. Apollo 1, Carnarvon.
Go.
Raj, we're reading a high battery manifold pressure. Would you confirm that your battery vent valve is open?
Stand by. Battery vent is coming open. It was closed.
Raj.
What was that last report, Chuck?
Okay, that's up pressure. Apollo 1, Carnarvon. Okay, that's corrected the battery manifold pressure.
Carnarvon transmitting TM off, low bit rate.
Apollo 1, Carnarvon. We're showing thruster number 11 on the service module RCS as open. Have you had any problems in that regard?
I've had the whole system shut down. Using it, we had no problem.
Roger.
Capcom, Houston flight.
Right, Carnarvon, go ahead.
Stand by.
Still got telemetry even though we're past our LOS time. We transmitted TM off.
Carnarvon, you want to recap your pass for me, please?
Roger, flight. Okay, we got the landmark update to the crew. They questioned the times, as you know. Okay, second item, the ground readings on the battery relay bus was reading 2 volts.
Roger.
Okay, and battery bus A and B were both off. The crew put these back online, powered up our transducers, and we got good readouts. Spacecraft was reading 3.7 and 3.7 open circuit voltage, and we were reading 3.5 and 3.6 respectively.
Okay, you're talking about the battery bus A and B, right?
That's affirmative, flight.
Okay, your battery relay bus, though, was still reading low, around 2 volts.
That's affirmative.
Okay.
Okay, he reported a failure in his optics sextant drive shaft. Of course, he couldn't use his shaft axis on his sextant.
Okay.
Okay, ground reading showed a service module RCS thruster 11 open. However, the crew said they had the system isolated, had no thruster problems.
Which one was that?
Thruster number 11, that was confirmed on the ground station readout
That's
also.
CM RCS? Or
Service
FM?
module RCS.
FM.
Okay,
Okay.
then ECOM reported that we had a high battery manifold pressure reading 21.6. We asked the crew to check his battery vent valve. It was closed. He went to open and our ground reading dropped.
Roger.
Stand by. Light reading on that battery manifold pressure at LOS was 0.6.
Roger.
So that's open. Okay, the S4B, we had a nominal pass. The tank pressures look good.
Roger.
That's it, Mike.
Okay.
Resolution on those landmark times.
Say again, Chuck?
Any resolution on the landmark time?
Yeah, it's a point of misunderstanding. I was talking to Jerry here, and the landmark time indicates those that are available, but not necessarily all of them which they must track, and we'll clarify this over Canton via the Capcom.
Okay, I don't understand it either, but I'll listen.
Okay.
We also had an abnormally long pass, and our real-time command apparently did not cut off the spacecraft telemetry. It was on that LOS, and our LOS came about 1 minute beyond our nominal LOS time, our predicted LOS time. So telemetry may be on. Copy, flight. Copy, flight. AMB, Carnarvon. Carnarvon.
Go, Carnarvon.
Raj, in addition to what I gave you, our TM was on about 1 minute beyond our predicted LOS time, even though we had transmitted TM off.
Roger, Roger, Chuck. I got other problems. Go ahead, Carnarvon. I'll pick it up.
Raj.
Go ahead, Carnarvon. What do you want?
Just be advised that our TM LOS is about 1 minute late, and real-time TM off command did not work. Couldn't cut it off by command.
Okay. Got anything else, Chuck?
That's it. Carve it out.
Raj.
Plans acquisition.
Canton, go remote.
Canton remote.
Apollo 1, this is Houston through Canton, over.
Roger, Houston, I read you.
Roger, things are looking good here. How are they up there?
We're fine.
Okay, got a few things for you. We'd like to check your computer navigation capability, and we want you to request program 24, verb 66.
Yeah, I'm getting feedback.
And we want you to read out latitude, longitude, and altitude at an input time of 001182000. And we can compare with what we have on the ground.
Hey, Jeb, repeat that. We were blocked out on the loop somewhere. We only got about a third of it.
Roger, we'd like to check your computer navigation capability, and we'd like to have you request program 24, verb 66. And we want you to read out latitude, longitude, and altitude at an input time of 001182000. What we're going to do is check with what you get with what we have on the ground.
Roger. Hey, Carnarvon reported we had thruster open on thruster 11, but we checked it out and it's working properly.
Okay, you checked the thruster 11 is working properly, thank you. Okay, and while you're doing the computer work, I might tell you the Carnarvon track gives you an 86 by 191.5, that's pretty good dope. And I have something for Ed or Roger. We'd like to know in the optics whether you've tried all the controller speeds or not, and both in direct and resolved.
That's affirmative. I've tried all 3 speeds and direction resolved. I still have a problem with the shaft. I'm unable to drive it. I have front-end drive, and I have manual drive with the shaft.
You do have manual drive, and I guess you've checked the main A and main B circuit breakers, right?
Roger on the circuit breakers.
Okay, fine. Okay, and while you're still working with the computer, I'd like to clarify, perhaps with Gus, the landmark times. The times that Carnarvon gave you are the only landmarks available that meet our cloud cover criteria, etc., but there's no reason why you can't pick other landmarks as you desire and attempt to track. No,
Roger.
And whenever you get the information on, from the computer, program 24, I'd like to have it down. We have about 4 minutes to go for a Canton pass.
HP 200. Oh, 2.026.40.
One, this is Houston. I have your longitude of minus 02060. Could you give me the latitude, please?
Plus 02640 for latitude.
Roger, plus 02640. Roger, how about your altitude?
It's all 0.
All 0, thank you.
D, Guaymas, Capcom on Goddard 1. Roger, AFD. You want to ask the crew to have TM turned on at Guaymas ALS. You're going to have Texas turned on by command.
Well, from what we got from Carnarvon, that they didn't get the telemetry commanded off, so it'll probably be on at your acquisition.
Okay.
Stand by 1. Head Guaymas.
Okay, we'll assume AFD TM will be on CSM.
Okay.
Take any action if it's not on.
Right. Okay, right now we're going through an internal tag up here on some of the problems we're having, and Flight Director will come to you very shortly.
Okay.
You may be aware that we have several problems. One is with the AGC, and we're going to run a new test after the state pass here, after we update the state vector. We have the optics problem. We're not exactly sure of the reservoir bypass problem in the ECS system. We're going to look at that again. There was a problem at Carnarvon with thruster 11 indicating on by telemetry. The crew stated that the thruster wasn't hung on. That's a service module ICS thruster, so you might be aware of that. It might be a common telemetry patching problem between all sites. We have the battery relay low voltage reading. We're not sure whether that's the telemetry or not, the transducer. We're going to look at that over the states. And we're not exactly sure of the battery charger, other than right now we think it's just inoperable. And we've lost the helium source telemetry measurement on the ground. Now, the crew said it was okay on the board, and they have some spikes on the reading.
Which helium source?
SPS. SP triple balls 1.
Roger.
And that's the status of the spacecraft right now.
Okay. You say if TM is not on acquisition, ask the crew to have it turn it on, right?
Roger.
Okay. Let's has PCM solid on the IU. Are transducers on those measurements? Okay, that's what he's talking about then. Master sequence control.
You're on the wrong loop, Wymus.
Wymus has acquisition on CSM.
Roger, Wymus. Hey, was the telemetry on?
That's affirmative. One, Wymus. Go, Wymus. Roger, would you give us a readout your cabin pressure reading, please?
Roger, cabin pressure reading 5.8.
Roger.
That's Capcom, Houston flight.
Houston flight, Wymus, go ahead.
Roger, we have the clues start a tape recorder rewind. We'd like to do a dump probably over Canaries.
Roger. Say again, where flight?
Not over Canaries, stand by. We'll pick a site. Just get them to rewind the tape recorder.
Apollo 1, Guaymas, would you start a tape recorder rewind for a subsequent dump?
Roger. We're not reading your pass, or Wymus, we're not reading your pass.
Flight, Guaymas, were you calling?
That's affirmative. Did you go to crew air to ground on that tape recorder rewind?
Right here, I'm reading you very weak. Say again.
Roger, did you go to the crew to get your tape recorder rewind accomplished?
Roger, they're rewinding the tape this time.
Roger. Okay, we're going to be primed for air to ground here, Chuck. I believe we're going to acquire very shortly.
Rog.
Texas, go remote.
Texas, remote. 39. Right around the bend. It's not quite sufficient.
CSM solid. C-van track, two-way phase lock. Apollo 1 to Houston, over.
Go ahead, Houston.
Roger, I have a couple of procedures which we'd like to try out during our stage pass this time to see if we can't isolate some of your system problems. Number one, what we want to do is, since you have a battery charger failure, is try to minimize the drain on the batteries as much as possible. And we like to have you follow a certain procedure. First of all, we like to have you put the second inverter back on the line so that we have a one on AC1 and number 2 on AC2.
Roger.
So let me know when that's accomplished.
That's done. That's complete.
Thank you. Okay. Now, we found out in an emergency, bus ties are no good unless the battery buses are powered. So we have an action which we'd like you to follow now to open up the circuit breakers feeding the battery TM and the battery relay bus. Are you ready to copy the circuit breakers to be opened?
Go ahead.
Roger. On the main display console 22, panel 22, your master event sequence controller A, logic A, bat A. MESC B, logic B, bat B. Battery relay bus, battery A, and battery relay bus, battery B. Texas, Houston. In the lower equipment bay, panel 150, battery charger, battery C. Will you pull those, please?
Roger, they're in work.
Roger, thank you.
They're done. They're complete.
Good. Now, during the pass over the states, we'd like to look down here on TM in your ECS system to find out exactly what the glycol problem is. And I have a procedure here which I'll read up to you, and we'll be following it down on the ground. Stand by. One, this is Houston. Did you get your entry batteries back on the line?
Roger, they're on the line.
Okay, your batteries are on the line, thank you. Okay, I'll read out this glycol procedures check if you're ready to proceed, one.
Go ahead.
Roger. The Glycol to radiator valve, below equipment bay 307, open. That's left-hand equipment bay, I'm sorry.
Roger.
Okay, procedure 2, ECS radiator switches, 1A, 1B, 2A, 2B, 2A and B on. That's main display number 21.
They are on.
On, O-N.
They are on.
Oh, roger. Glycol reservoir, bypass valve, left-hand equipment bay 307 to open. Roger, Glycol reservoir outlet, inlet valves to close.
Close.
Roger, Glycol reservoir reserve valve, the left-hand equipment panel 311 to off.
Go level.
Texas Seminole, yes, the pump pressure goes to 0. Turn on pump 2 on the main display console. Is it 0 now, 1?
Apparently it is.
It's 1, and we've tried pump 2, and it's still 0.
Okay, fine. And if the pump out pressure is still 0, go back to pump number 1 and leave the reservoir on the line.
Roger, we're back to 1. We're putting the reservoir back in the line.
Okay, fine. Thank you. One, this is Houston. We're going to try to uplink a program 2776 to you at Mila. Could you get the computer and prove over?
Hi, Houston.
Go ahead, one.
Our computer is hung in program 24.
The computer is hung in program 24. Okay, stand by, one. Well, while we're waiting for that, since you're in program 24, can we get another latitude, longitude, and altitude for a time of 0004940?
I'm afraid not. It won't move.
Oh, won't move, okay. Oh, stand by. Disregard that last comment. Bermuda, go remote.
Bermuda remote.
Remote. One, this is Houston. I got another little check for you if you can. Could you momentarily close the bus ties and give us a read on battery A and battery B current?
Okay, bat bus A current is 10 amps. Bat bus B current is 10 amps.
Roger, I understand both A and B are 10 amps, thanks. Okay, and you can reopen the bus ties.
Roger, they're off.
KV, Capcom, Houston flight.
Flight RKV.
Roger, the tape recorder is rewound. We would like you to take a low bit rate tape dump from the flight crew.
Roger. We've got problems about analyzing the data afterwards. We can record it, but we can't play it back.
Why not?
Our tape recorder's playback capability is down.
Okay, you can get it fixed. Take your low bit rate dump.
Roger, will do.
When it's complete, get it rewound and go back to low bit rate recording again.
Roger, will do. RKV has acquisition.
Roger, RKV.
One RKV. One RKV.
Bermuda, go local.
Bermuda low.
RKV. Roger, you're looking good here on the ground, and we'd like to get a low bit rate tape dump from you. Okay, place your speed switch to high, forward reverse switch to forward, tape analog switch to tape, and your record play switch to play.
RKV, Capcom, Houston flight.
Go flight.
Roger, you don't have to take him through the procedures. Just tell him what you want. He's got his slide rule on board, and he'll use it.
Roger, very good.
KV, Capcom AFD.
AFD, RKV.
Do you have RTC capability?
Negative. One RKV. Okay, we've completed the dump. You can start rewinding the tape. When you have it rewound, you can go back to low bit rate record. FD RKV.
Go ahead, RKV.
Okay, we're coming up on LOS. Do you want us to have him to turn the TM off, or do you want to let it go?
We'll catch it at Canary.
Roger, thank you. Apollo 1 RKV, we're 1 minute from LOS and standing by. RKV has LOS.
Wireless Capcom AFD. Wireless Capcom AFD. Wireless Capcom AFD.
Go AFD.
Did you see the thruster 11 indication on your pass?
The Capcom is not here right now. GNN did. Capcom stepped out a minute. I'll have to call you.
Thank you.
Canary has acquisition.
Canary, go remote.
Canary remote.
Go ahead, Wymus.
That thruster indication we've got, that thruster indication was confirmed out of the PCM ground station. We don't...
Apollo 1, Houston, through Canaries, over.
Problem on site.
Say again, Chuck.
Oh, Roger, we'd like to reset the RTC relay that was hung up and have just a small procedure for you to do that.
Roger, say again, please.
Roger, we want to reset an RTC relay on board, and would you verify the C-band switch is in 2 pulse?
Roger, it is in 2 pulse.
Roger, and the up telemetry command switch is to reset momentarily? Thank you.
Wymus Capcom AFD.
Apollo 1, Houston, we're about 1 minute from LOS. It appears to us here that you might have burned excessively, and we're estimating at this point perhaps a short touchdown. We'll keep you informed. Apollo 1, Houston, we're also going to try to pick you up by AutoCAT relay out of Hawaii. Over.
Range tracker has LOS. Tech Hawaii Comtech, we have AutoCAT acquisition.
Hawaii, go remote AutoCAT.
Roger, AutoCAT is remote.
Apollo 1, Houston.
Go ahead, Houston.
Roger, we're working you through AutoCAT at this time. We show you're going to land about 34 miles short. Coordinates are 31 degrees, 11 minutes north, 157 degrees, 16 minutes west. An aircraft rescue 1 and 2 should be overhead in about 50 minutes. The D.D. Phillips Should be on station in a little over an hour. Over.
Roger.
How did re-entry go, Apollo 1?
Well, we're right in the middle of it still.
Roger. How does your drogue look, Apollo 1? Apollo 1, Houston, how are your drogue in Maine? Over.
Say again?
Roger, we were trying to get an indication of how your drogue chute and main chute are performing.
Pulling 10 Gs right now.
Roger.
Houston, Apollo 1.
Go ahead, Apollo 1.
We're down to 40,000 feet now.
Roger.
Space Jettison.
Roger.
Move to that.
Roger. Apollo 1, Houston, do you have a readout of your present position?
Main chute.
Roger.
Houston, Apollo 1, be advised the AGC is inoperative. We have no readout on the latitude, longitude, or delta R.
Roger, so far we don't have any fix on you from a recovery aircraft. We still suspect you're about 30 to 35 miles downrange, correction, uprange.
Roger.
Hawaii, contact. Hawaii's AutoCAD has LOS.
Roger.
Apollo 1, Houston flight, do you read? Apollo 1, Houston flight, do you read? Listening.
Okay.
Okay, let's see if we can get all flight controllers, go over to Goddard Conference for debriefing.
We don't have a Capcom here yet. Maybe we better wait for him.
Okie dokie. Apollo 1, we'll be back to you as soon as we get a Capcom. I'm in here. He's taking a short break. Apollo 1, Houston flight, do you read?
Go ahead.
Okay, Gus, I'll make this pretty short. We had a large amount of problems, and we won't delve too much time and beat a couple of them to death. The launch phase was essentially normal up to about 7 minutes. 7 minutes, you made a report that you had no onboard GNC data, and very shortly thereafter, we lost all ground telemetry data, and shortly thereafter, we lost our trajectory data, all sources. At this time, Fido went to the RSO and continued to get reports that the launch vehicle was burning, and they got a very precise hack at the cutoff time. At cutoff, we obviously had a problem. We had no data sources to base our go-no-go on, with the exception of the fact that the RSO had been reporting in. Everything seemed normal there, and the fact that the cutoff time was normal. You, in the meantime, came down and read us that you had 1,100 foot per second delta V, and you read us your perigee time and advised to the fact that you had no TFF. At this time, going over the data that we had both on board
and here in the ground, particularly the RSO data, I believe Fido decided that you could not have, or those indications on board could not possibly be proper due to the cutoff time, and he recommended a burn of about 200 foot per second to handle any small dispersions either in cutoff or flight path angle at cutoff. And that's how you got your 200 foot per second. Okay, after that everything seemed to be relatively normal until we got to Carnarvon, and we started picking up a couple problems. As a function of your checklist, you advised that you weren't able to isolate your reservoir, and you had to leave your reservoir in the loop to get normal flow. In addition, we had a battery relay bus problem that we troubleshot later. You advised you had a sextant shaft drive failure, and Retro by this time had concluded that your GNN system was probably no-go, and we were going to make some checks on it. In addition, we had some bi-levels, service module thruster number 11, battery manifold pressure reading high, several other functions. We set these up over the states to start checking these out one by one. We got you into a configuration where you had minimal drain on the entry batteries, and yet you still had your entry batteries online. We wanted them online in case you had any fuel cell problems, such that you could use the bus ties and have power available immediately. We attempted to get a better hack on the optics. You gave us this and advised us that you could manually drive them. We confirmed the instrumentation problems, and at that time, we were still in a pretty good configuration. We brought up a second inverter, and that was about it until John Hodge took over.
Okay, we got the dump complete over RKV. That's an interesting point there, because we'd like to have looked at that data later, and weren't able to. I guess we have to be very careful about these early dumps to make sure that data is retrievable. As I understand it, it wasn't retrievable on the RKV, but it's something we ought to think about. Guidance indicated that although the crew had this problem on board with the computer not being able to get it out of, I think it was program 24, we wanted to see whether from the ground we could control the computer and get some data out of it. In fact, it may possibly have been an onboard diski problem of some kind. We recognized that was rather slim, but we thought we'd try it anyway. See, at that time we had 139.5 amp hours remaining on the batteries, which was above what our minimums are there. I think we're using 120 right now as our minimums on that. Just about then we started to lose pressure on our service module Quad A RCS, and told the crew that we ought to isolate that, and reminded them not to use the quad because we didn't want to drain the lines there. Also, the crew were pointing out that the helium temperature on Quad A was 0, which tended to indicate that we'd truly lost that quad. See, when we got over Carnarvon, we looked at that, and our pressures were agreeing with those on board, but the temperature was higher. However, in spite of that, GNC believed that we had in fact totally lost that quad, and we might have a little bit in there from the regulated pressure, but that was about all. We sent poo from Carnarvon, but we didn't get any downlink indications, which, although the thing was accepted on board, it seems as though our commands were getting in, but since nobody could make any readouts at all, either on board or on the ground, it really was kind of academic, so we really didn't have a computer. That was about it. Then Gene got it back.
Okay, at the time we picked it up, the first item we advised the crew was to restrict any activity on the service module RCS or any usage of the service module RCS until we had a better hack on the red line. By that time, the battery vent pressure had come back in, and we got a report from the crew that the fuel cell currents were reading about 45 amps on fuel cell 1, 2, and 3. However, the main bus voltages were reading pretty good. They were reading within limits, 27.5 to 28. and we logged this as one of the problems that had to get nailed down. In the meantime, GNC came up and advised that with the RCS red line for a 3-quad RCS deorbit, we could not expend any fuel for probably the next couple of days, which brought up an interesting flight plan item here. I couldn't see, based on the flight plan, going a couple days in essentially drifting flight with only limited RCS usage. So we took a look at how we could go ahead and get a good hack on the SPS that would enable us to continue to use the service module RCS as required. And we were working out a plan that would possibly allow us to burn in the 4th rev over ascension to get a good qualification on the SPS. And this is based on the ground rules as we presently understand they will be written. This is still a point that has to be talked over, but it was a good exercise there. However, about the time we got over the continental United States, it looked like we had a new problem developing that defied all reasoning, it seemed. First indications were is that O2 tank pressure 1 started to decrease. Simultaneously with this, the surge tank pressure followed it down within about 10 to 20 psi. We thought we probably had a manifold leak into the cabin. However, the cabin pressure was not building up to confirm this. Okay, we continued on across the states monitoring this problem. The crew advised they did not have an O2 flow highlight on, so we weren't venting through one of our other relief valves into the cabin. The item we tried, we had communications problems trying to get the crew. We wanted them to isolate or close the surge tank pressure relief valve to see if possibly we were relieving through that valve. The problem continued, and we looked at it again at ascension and tried to get it nailed down. Still had no reason to believe that, let's put it this way, it still didn't make sense. As we were coming across Carnarvon, though, we had computed that if we actually were venting our O2 tank number 1 at the present rate, the O2 tank number 2 should come online and give us an indication through not our manifold, but our regulated pressure. And we were watching this very closely at Carnarvon. At the same time, I had the Capcom reading up the data for landing area 3-4. Carnarvon, we thought we saw the O2 tank number 2 come online, and when I say come online, what happened is this. The O2 tank number 1 had dropped below 100 psi, and our regulated pressure had essentially leveled out, which from our standpoint meant that we were starting to flow oxygen from the O2 tank number 2. And as such, we advised the crew we would not deorbit for 3-4. We'd continue to look at it and see if we could pick a better landing area with more time available. And that's basically the way the problem stood as we came across the states. Now, one other item that occurred over Carnarvon is we did see a rise in cabin pressure to about 6.3 psi, and that seemed to confirm the fact that we did have a manifold leak into the cabin and that we were venting overboard, at which time Chris picked it up.
By the way, Gus, I'm going to ask Mr. Kranz for a detailed briefing one of these days and see what we get. We tried using this valve to turn off the oxygen supply, and that seemed to change the surge tank pressure, which completely floored us, and we were unable to understand that. We asked for a rundown of what the actual valve positions were and found out that we better get back in a condition where we had some control over it, and that's the reason we closed that valve again, closed off the surge tank, and went with the re-entry oxygen, and assumed we only had 2 hours of re-entry oxygen left. I guess simulation will try to give us an explanation of how that situation can exist. We don't understand how it can happen. We then wanted to get some understanding of an alignment, and we gave you an alignment procedure for using a boresight star since the optics were out, and gave that to you over 1000. We weren't sure that you'd be able to get the thing aligned in the time you had, but evidently you reported that you did. The rest of the flight
as far as we were concerned, went pretty normally in getting you the information necessary for retrofire. The updates all seem to go okay. The attitudes that you had at retrofire appear to be improper for some reason, and maybe we can get some idea of that from either GNC or the simulation people and why the alignment was not proper. You got a little bit high retro velocity, so you should have landed short, but actually the times of drogue and main were about 4 minutes late, and you were considerably downrange. Let's go to you, Gus, and see what you want to say about all this good stuff.
Well, Ed and Roger's got the notes. I'll let Ed go ahead with his notes there first.
Okay.
Okay, we'll start right at the beginning with a modest account, but on the pre-launch, we didn't have any of the pre-launch data, -1, etc. The problem also, you called us and asked for a helium pressure readout, and you got to specify which one. We have 3 different systems using helium, so you have to call that out to us. It led a little confusion in there, I think. So about 100 feet per second, we had a minus 360 degrees altitude. That wasn't in time, that was a perigee altitude, and we were not indicating any TFF on our DISCI. So with this display, we went into our chart, assuming a nominal burn 1100 delta V. Yeah, but I think we had to assume our GN wasn't any good right from the start. We didn't have any TFF, so we wouldn't have believed that. Right, we report our GNN was down.
Yeah, I guess we're interested here in the explanation of this whole bit from Fido, so we'll expect to get that from him.
Right. Okay, we also, I thought we'd be getting some CLA updates shortly after we got up there. We didn't really get any until we got the update for 3-4A, and that was given to us approximately 10 minutes before retro time, which was really too late to be of much value to us. And at that time, we didn't have a computer, and the information that we received at that time was more based on having it.
Okay, Gus, in the 2-1, we were ready to give it to you, but our computers were down for a total of about 30 minutes here. And by the time we had got it computed, it was so close to the retro time that we would have had to spend about the last 2 minutes of the Carnarvon pass to get it up, and it didn't seem worthwhile.
Okay, we were looking for that over Carnarvon. Okay. The procedure for the backup alignment on that you called up to us wasn't too clean. We got angles that came up as a pitch, yaw, and a roll when the normal formatted up is roll, yaw, roll, pitch, and yaw, which we didn't have a format for that. We might work up some kind of format to have you call that up to us. But the angles all came up in different sequences. And again, this is another small point. We don't need an altimeter setting. We can't set it. And I think probably we need simulation before we go into what happens on our reentry. I think we have a lot of simulation problems in here that compounded with your problems and added things up that we had going on in the spacecraft. Yeah, right after retro fire, in fact, 2 minutes after we fired, just we got ready to separate, all hell broke loose in the cockpit. We blew all the circuit breakers down the lower equipment bay and put them back in, and lost your pitch attitude, your fall, spun up. We did about everything. So I'm not surprised that we came in a little long.
Roger.
One thing to the Capcom too, when we switched from a card, we did it only one time, and we'll discuss it later, but when you switch from one card in our book to another card, you have to give it time to bring that one, fish that one up, and start commenting on it. That's all I have. I think Roger has it.
Hey, Mick.
I have a couple. The first one, I was a little baffled why we went to the 2 inverter configuration when we realized we couldn't battery charge. We were trying to save battery power, and I didn't understand why we powered up the 2 inverters at that time. And maybe Ecom can clear me up on that. And then again, what Ed said on the retro updating there, on the first one for 3-4, we got a deorbit target update and then an abbreviated entry, and then we got the angles for roll, pitch, and yaw. And I was a little confused at the time. I thought maybe they were the angles for the entry interface, 300K. And when Gus looked out the window and looked at the horizon and star field, we figured out that they were probably the retrofire angles. But if they're going to come up with remarks, it'd be nice if we get them in the remarks for the deorbit target update prior to getting the abbreviated entry update, because that is on another card.
I had a question. Are you using the actual cards that we have in the book or some switch form that you have?
Gus, we're supposed to be using the same, we made a big, we're supposed to be using the same cards that our pads are supposed to be exactly like what you guys have in your book. And
there was a big ceremony this morning there, Gus, when Jerry Jones came in and handed out all the books.
And now I guess that thing, the thing that he just mentioned about the 3-4, what we did there, and probably this is a brand new procedure, we had never talked about it before, but what we did there, since we had a feeling that your IMU might not have been aligned, we gave you some pitch, yaw, roll, pitch, yaw angles at a time approximately 2 minutes before retrofire, so you could go ahead and get, check your IMU there, and get a feel for how well your IMU was lying there, and if it was good, then you could go ahead and use it. If it wasn't, you could go ahead and align your AGCU, and that's what those numbers were, and usually those pitch, yaw, and rolls were at either at ignition or for re-entry interface, and that's probably where we got screwed up there. We'll try to do something about that. Do you see what I'm saying, Chaffee and Gus?
Yeah.
We passed, I guess we put them in the wrong place, and I guess simulations kind of take care of that kind of thing. Don't you think that's a good idea to do it that way? If you don't have a chance to get a star, say a boresight star?
Hey, John, I can't talk. Well, you talk. Hey, John, that looked good to us, and we were just a little confused. First, we thought they were the angles at 300K or 400K.
Okay, then where do you want us to put these numbers then, Chaffee? Because we'll sure do it. What?
They should come at the end of the deorbit target update if they're going to be some sort of a backup, shall we say, for the retro.
Okay, in other words, they'll come right before the abbreviated reentry if we're going to do anything like that, huh? Those numbers.
And then, like Jim and I talked the other day, Ed mentioned call-out, we're going to do the abbreviated entry or the deorbit. This lets us pick out another card to record it on. Another thing I had for flight planning, I guess it was after the fact you asked us how our retro orientation mode A and B went, whether it was satisfactory or not, but we never got updated with the ICDU angles for the retro orientation, which we're supposed to compare after we've flown to it to determine if it went okay or not. So we missed that flight plan update there.
Complete silence here. This is Carnarvon. I queried AFD about the flight plan update over, I think, Rev 2 on Carnarvon, and the report was that we weren't no longer following the flight plan because of the problems we had going. Well, okay, I'd like to know.
That's affirmative flight, according to flight plan.
Okay. I don't understand all that, but that's on.
I don't know how the simulator here interfaces with MCC too well, but I think I probably screwed up the dump at Carnarvon unless Tim was playing back a tape for you, because we kind of got confused on our voice reports again, and I was rewinding, and all of a sudden I heard RKB say dump complete, and I really hadn't started the dump yet. I was still trying to rewind the tape recorder.
Yeah, well, that's a problem in the simulation, in that they really don't want you to be dumping data, and I guess we've got to play sort of a game there.
Okay, well, sim people here finally told me that, so we quit throwing all those switches.
Roger.
We screwing up your data.
Roger.
Hey, Roger, you know about this business of not being able to dump backwards on the tape, do you?
Yes, that's why I was rewinding so we could dump it forward.
Okay.
And then I I have a question when we get the ecom again about what was meant when the number 2 tank appeared to come on the line, or the number 202 system. As soon as this pressure became greater in number 1, because number 1 bleeds down, it seems like we would see that same pressure to the inlet side of our main regulator there, and number 2 system would have been supplying oxygen to the ECS system.
We don't understand that either.
Well, maybe our sim people here will say something about that problem.
Roger, this is Ecom. What we were saying, we knew all along that it, like you said, the high tank should be supplying, but for some reason it didn't look like it was. And then all of a sudden at Carnarvon, when tank 1 got low enough, we saw an increase in the use rate out of tank 2. That it sort of looked like it picked up what tank 1 should have been supplying, but none of it made any sense. That's what we meant though when we said we saw it come on the line. Just all of a sudden, as if by magic, it started supplying more than it had been.
I see.
Would somebody say something about 2 inverters while we got that question on the floor?
Slide that. This is simulation. That is required to make the AMS run. That's why you had 2 inverters online.
No, you wrong answer to different question.
Okay, we're talking about 2 different things then.
It was actually 2 other guys. It's all right.
How about that, Ecom? Would you explain that, please?
Okay, when I came on, we were in the 2 inverter operation, but apparently there was some concern over the battery relay bus, and when there is any concern over that, you do want to be in a 2 inverter configuration, because if you should lose that bus, of course, then you're stuck with the inverter configuration that you have.
You follow that, Roger?
Yeah, I sure do. I thought we were just trying to save power, though. We didn't have any problem other than the battery charger wouldn't work, and we just disconnected the battery relay bus to save the battery.
Yeah, I guess our point of view is, however, Roger, that we want to fly with 2 inverters on the line, period.
I see.
Because we do have a feeling that we don't want to, we can't see jeopardizing the whole flight on the basis of flying only on 1 inverter and being in a position where we would lose that one and then not be able to get another one on the line. And we intend to discuss that with you during the mission rules briefings. Silence.
I'll trade with you. We'll put 2 inverters on it if we'll rule out a 3-quad orbit.
Okay, yeah, I think we're probably somewhat in agreement with that, Gus. But I think, I discussed that with Ed a little bit when I guess you were out somewhere, what our feeling is to date on the command module RCS reentry and all that good stuff. Our problem at the moment, however, is getting a feel for what the backup procedures will be when you lose the GNN system.
Well, with a 3-quad orbit, I don't think you'd ever know whether you had enough cell to be entering or not. You'd never know.
You mean from the standpoint of the attitude control problems you run into?
That's right.
Yeah. Okay, we'll be glad to discuss that then. Because I think if we can get some answers to this other thing, we're willing to go to this command module RCS system as the backup, but we've also got to go with the proviso that until we have proof that the SPS system is operational and reliable, that we're going to save the RCS system as the prime method of deorbit.
I'll buy that.
Okay. Okay, let's go see if anybody else has anything to say in detail here. How about Booster? You have anything to say?
No, flight is fairly nominal for us.
Okay. Retro?
I got a comment on the 2-1 thing. I think Kranz misinterpreted something here. We had the computers back up at least about 10 minutes, or probably 15 minutes elapsed time, and I had all the 2-1 data at Carnarvon, and at that time I sent it but for a closed loop reentry. But at that time, while I was doing it, just to get myself ready, but at that time I had come to the conclusion, at least we had on the ground in the trench, had said that was something wrong with the GNN, and we really should do an SCS Delta V, and I had at that time sent that stuff out, and then we had the problems over Carnarvon, so we, I mean, it didn't look like we were coming into Carnarvon, so we wanted to pursue that. The other thing about what happened in launch phase, when we had all this loss of power and data and so forth at Houston here, it was this business of TFF that Fido and I came up with, that we got the same charts y'all used. We decided that you had a clear go from a number of things besides the data that you read down, because when you said you didn't have a TFF, it meant to me that you couldn't even get on your charts, and we might have misunderstood that, because I thought that meant you had a 5959, and you could not have a burn in the orbit for 1100 foot per second in that case, and that's how we interpret it here. I'm sure Fido has some more things to say about this. The other question is that everything, we went okay and discussed the different alignment modes and so forth, but what happened at retrofire, I think, well, I'd like to make a comment. That Delta V that you send down is, Gus, I guess today was a total Delta V. That means it included the tail off, and I was assuming first it might just include what the Delta V counter was. And then my other question on that, and this might be just a sim problem, but what cut the SPS engine off? Did you actually cut it off, or did the Delta V counter cut it off?
Right, with the manual cutoff, and the reading did include the tail off.
Okay, that's how we finally got it here. Okay. And it looks like another thing, Gus, that you were not in the correct attitude at retrofire. At least here, we looked back at the attitude, the pitch attitude, and it looked like instead of being at 228, that you might have been at 185, and if we put that number in that Delta V, we would have gotten the numbers that matched you when you got main times, and that's about all I got to say.
The Boresight star you looked like it was probably in about the right position, the right attitude. We don't have a sight in here to check it.
Oh, that's right. Okay.
It looked pretty good, and we do have a meter in here that gives us a reading below the local horizon. It was 223 degrees, I believe, at retrofire.
Okay.
Which is below the local horizon.
Right. That was about what we said you should have been. We said it had been 228, but we got data from telemetry that said you were at about an attitude of 185, which was about, so and that pitch attitude, by the way, Gus gave us the numbers that matched your drogue times, which put you further down range. Okay, that's all I got to say.
Okay, Fido.
Okay. As has been said many times, we lost all our data. And just before we lost the data, we had on the plot boards what was apparently a small problem in the IU, in that the IU was telling us that it was nominal, while the radar data showed us to be slightly high, about 0.2 of a degree in flight path angle, and to be a little bit slow, maybe as much as 100 feet per second.
Where did you get that information?
Off the plot boards, Flight. Okay, and then we went on.
How can you get data off the plot boards when you lost data at 7 minutes?
So at 7 minutes, that's what the data was saying before I lost it. Okay, at that time, at 7 minutes, I had that much of a dispersion that apparently building up on the plot boards.
Okay.
Okay, we went on and we got the cutoff. The RSO told me it had cut off, and the time that he gave me looked like it was at least nominal, or just a little bit more. Okay, I did not copy the PMR shift problems that the booster people had, so I didn't know that it was supposed to burn a little bit long. But the cutoff time looked very near nominal to me, which said to me that the booster looked like it was about right, that it cut off based on when it thought it had got in orbit. And because I had seen the high flight path angle and the low velocity, I said it has to have a small positive flight path angle and be a little bit under speed. And I didn't say anything then, and then when I heard the crew come down and say, we need 1,100 feet per second, I said to myself, there ain't no way. Okay, but that wasn't right. That was the first mistake. But if they did not have a TFF and they had a minus 360 perigee, I don't understand how they got the 1,100 feet per second delta V, and I'd like for them to tell me how they got it again, because I missed it initially. Now,
this is it.
go ahead.
I explained it earlier.
I have a
Nominal flight path, and so we have a line on our chart that shows. Because the TFF was at 59, and has been that way for some time, and I had no confidence that the AGC was working.
Well, that's the way we interpreted it, Gus, here. We thought that since the TFF is 59, there was no way you have a minus 300 nautical mile perigee, and we just thought the GNN was no go.
In addition to this, Gus, you had made this report earlier in the launch phase about 4 minutes and said that you had essentially no data there from your AGC.
We were trying to indicate to you that our AGC was no go then.
And that's the only reason I went with you, Fido. That's what the vote was cast. When he read those numbers out, I was going on you as a data source.
Okay, now.
Okay, now, on that basis, how did you come up with 200 feet per second?
Okay, the 200 feet per second was done by saying that from all the data I had, the cutoff time that I had, and that the errors that I had at the time we lost data, the only thing that I did with that was try to extrapolate it out the cutoff and say, if I had these errors now, I should have had this error at cutoff, the divergence of the thing. Okay? Looked at the chart and it said I needed about 100 feet per second to get clear. I padded it by the 100 feet per second to be sure that I didn't read the thing wrong, knowing that I had a positive flight path angle. By doing the maneuver, I would make it more positive and I should at least get the Canaries. Okay, and get some radar data there and see what the true state of the orbit was by making the flight path angle positive. Now, there are many questions about this, about whether or not you can extrapolate. Okay, and at that time, I did not feel I had a choice. That was all that was left to me. And the other thing was, it's kind of hard to predict whether or not apogee is going to be on the other side of Canaries or not, so that you have a chance to recover it.
How about, what did the IU show at that time?
We had no data flight. Absolutely no data from
No, I realize that. At the time you lost data, what did the IU show?
It showed that it thought it was nominal, and the radar showed that it was a little bit slow, and a small positive flight path angle, small positive error.
I guess I would have, my guess would have been, I would have been prone to leave it as is and say that the IU was right.
But I have the radar sources were not confirming that flight. I showed a small bias in the first stage on the MILA data, and I still had the bias when I switched to the GBI data, so there's no way for the IU to be right. I had two independent sources tell me that I was developing a small problem in the IU data. So I cannot believe that it's right, that it's perfect, if you will. Okay, I think that we in the... We in the FIDOs here, with the old problem, with the things that we're doing, did not know that you were having trouble with the GNN at 4 minutes. The first inkling that I had that there was a GNN problem was when I heard the minus 360 and 1,100 feet per second, and I and myself said that can't be right.
Yeah,
I didn't know that you had a problem before that.
Because I was the one that told you about the TFF, and we went to the charts, and there was no way to do that.
I guess the other thing was, Phil, that up here we didn't know that you had a S4B bias either.
We know that we had lost all the data before we had gotten enough of it to really know what we were going to do with it.
Yeah, okay.
Because it was very small still when we lost the data.
Yeah.
And we just hadn't had time to confirm. We could not really confirm the thing and be absolutely positive sure that that's what had happened. So when I got into this other situation, I had to believe the data that I had.
Yep. By the way, did Sim do that to us?
You mean turn all the RTC down?
Yeah.
Negative.
Okay, how about guidance?
Okay, I'd like to add one little more comment about that loss of data in the report there, Flight, in that the period that we lost the data was about a place where we usually get our best assessment of what the problem is. We did notice the bias in the first stage, but at that point usually it's real early to try to assess it and really determine what it is. Then we're waiting to do that, and then that's when we lost the data. Now the bias was small, but looking at it, it did look like an accelerometer problem because it affected both the velocity and the flight path. So I think it was an IU problem at that point, but still we couldn't confirm it at that point. Then the other comments I had was this AGC problem. We tried to check its navigation after we inserted, and we got a real funny readout from the crew on its ability to determine where it was in its own orbit. Then we wanted to update its nav vector and try the same thing again to still check out this ability. And that's when we determined it was hung up in program 24. And that's when we tried the command system over Carnarvon to put it back to program 00. The command system said the data got in, but the crew neither the telemetry would confirm it. And checking with the software people, this just isn't very, very realistic. And I'd like a confirmation that this was a sim problem or what.
Will, this is Carnarvon. Yeah, the STEM people, I think, put data into the computer, but we really don't have anything in the way of command.
This is simulation. We transmit the load to the AMS, and we cannot verify that, in fact, they are operating on it properly.
Can you verify that they get it, though?
Only by having him look at it when he comes in his computer down there. That's all.
I think you're beating a dead problem there, Will.
Okay.
I do too. I think that's just a simulation problem.
That just bothered me awful bad. It's what I do there, and it really had me going for a while.
Yeah, I don't think that's a realistic problem.
Okay.
Flight this Fido again. On that Delta V they read us after that deorbit maneuver, we got into confusion down here in the trench because we didn't know whether he had added tail off Delta V or whatever he had done to it. Okay? And I think that we can get that problem rid of if he will just tell us what that Delta V counter reads.
That's what he read.
No, sir. If the number he should have read us for the Delta V he read us should have been 99980.
Oh, I can do that if you want. I just gave you the...
I think it would get rid of confusion for us, Gus, if you could do that. Because we know what you set that counter to, okay? And we get the thing down, and we got a couple of guys that can look at it here and be sure we get the right number out of it. So there was a moment of confusion on our part about what that Delta V really meant to us.
Oh, why don't you just recognize the Delta V I give you as the total Delta V? Because we might have our counter set on that.
Okay,
it doesn't make any difference as long as we know what you're doing.
Okay, it'll be total Delta V.
Hey, John, I had a question. Why did you set the retrofire up so that it was just at Guam LOS? Couldn't you have backed off the Delta V there a little bit and had it nearer the center of Guam?
We did have it there one time. The trajectory changed.
Sorry about that.
Okay. We had it fixed. We would have done that.
Okay. Just so we all aren't off the hook here, I don't understand all that good stuff you did there with that 200 feet per second. We'll beat that when we get through with this thing, okay?
yes, sir.
Before we go on, can we bring up again this AGCU alignment that we were talking about there prior to retroburn? we had a method there of giving the crew either 2 alignments with that AGCU if he failed the start check on the IMU. If he had gone into the attitude and had looked for that star and it was not there, we could have aligned the AGCU to 2 different orientations. One to what the IMU should have been, one to a preferred orientation. In a case like this, I don't believe it was really clear because the guidance officer on that shift was saying to go in and put it to the preferred orientation, and yet you directed to keep it to what we knew to be the current IMU orientation. In a case like that, what would you prefer to do?
Well, we prefer to do just what we did,
to keep it to something you really know then, right?
Right.
We'll beat that when we get through with this thing, okay?
Yes, sir.
Before we go on, can we bring up again this AGCU alignment that we were talking about there prior to retroburn? We had a method there of giving the crew either 2 alignments with that AGCU if he failed the start check on the IMU. If he had gone into the attitude and had looked for that star and it was not there, we could have aligned the AGCU to 2 different orientations. One to what the IMU should have been, one to a preferred orientation. In a case like this, I don't believe it was really clear because the guidance officer on that shift was saying to go in and put it to the preferred orientation, and yet you directed to keep it to what we knew to be the current IMU orientation. In a case like that, what would you prefer to do?
Well, we prefer to do just what we did,
to keep it to something you really know then, right?
Right.
Okay.
Okay, how about GNC?
Okay, quickly, the quad leak, after the crew isolated that, we noticed the source pressure kept dropping for a while, and then it came back up, and then we noticed that the manifold pressure had bled off, so I assumed that was a manifold leak, and I'd like for Sam, when he gets around to him, to talk about that. But I did call it no-go, and I think we actually had lost it. We quickly started running through this 3-quad budget thing, and I threw some stuff out in real time, like operational reserves and mixture ratio uncertainty, which I have talked and I think have finally got people convinced is included in our gauging uncertainty. And I actually came up then with, for a 3-quad deorbit, that we needed 151 pounds remaining in each quad. And at that time we had about 175 remaining in each. And I was trying to get to the flight director at the time, who was Gene, and he was all tied up with an ECS problem, to let him know that we actually had about 25 pounds in each quad we could play with. But about that time the ECS problem really got hold of us, and I felt that I knew they'd bring it back up to you, Gene. But we did have about 75 total pounds to play with before we got to what I would call the red line. And there's some considerations you ought to think about there, that every time you do a SPS burn, or of course fix the orbit up, your 3-quad deorbit red line goes down, particularly if you get weight out of the spacecraft. So the SPS burn that Gene had in mind there would have helped that red line considerably to burn some of that is, to reduce the weight of the spacecraft. To play the game fully out here, we had Span go to the program office and talk about how we could qualify this engine a little bit earlier. And I thought I might throw this in here right now for everybody to be thinking about before we talk about it some more, I'm sure, maybe this weekend. And that is that the answer we got is that they feel that anytime you burn the SPS, you're just degrading it that much more. So that probably the best thing you can do if you've burned it once and it worked is to say it's go. And I think we'll want to think about that one a bit.
You would already burn the SPS once, and you had it.
Raj, what I'm talking about, Gus, is we had talked about here what we had to do to qualify the engine, and let me just say that the initial look at it is that we'd want to burn the engine 2 or 3 times to fully qualify it. And what I'm saying is that that's not the answer we got out of the program office today, and so obviously we'll want to talk about it some more.
really what he's pointing out there, Gus, is the problem we're going to have in real time of determining when we're willing to consider the SPS go and give up the RCS deorbit capability.
Sure, I understand it.
And in my opinion, I think that's probably after we've done a hot and cold soak. Because I'd like to know what's going to happen to that engine after it cools off or after it heats up.
Okay, well, think about it.
Okay. How about Ecom?
Yep, I have one more thing here I'd like to bring up, and that's for this loss of a battery charger, disabling the battery relay bus. This is something we're going to want to talk about in the house, but if I could just point out how I feel on that. The only reason for disabling this battery relay bus, the only big current drain you have there from these fuel cell disconnect flags. And it seems to me that we'd be a lot better off to go ahead and just put the fuel cells on both buses and get rid of the flags, rather than disabling especially all our AC protection that we've got there. Because I think we probably stand a lot better chance of having one of these inverters go over voltage and wiping out some other piece of gear than we do in getting a gigantic short on one of the main buses, which is the only disadvantage in having all three fuel cells connected to both buses. So that's something we want to think about, but it sort of seems to me like that might be a pretty good mission rule for loss of battery charger.
Okay, how about Capcom?
First, got two things. One, I thought I did way too much talking with the crew. It seemed like almost every time we were over station, we spent the whole pass over station discussing one thing or another. And the second thing was when we weren't pressed for time, all these updates that came in and all the wording and switch throwing and what have you came in pretty detailed and good format. We didn't have any trouble. But when time got a little short, then I started getting a lot of information on pieces of paper and a little bit disjointed. And I think maybe we might want to just wait a minute and put these things down in good format so that we can pass up and the crew will be a little bit clear on what we have. I don't think we ever really ran short of time, but I know I'd be calling up there pretty rapidly, and I wondered if crew was going to get them. We didn't have to that way, Al, but after 5 minutes, we're pretty busy in there, so we'd appreciate nothing set up except what we really have to have.
Well, I couldn't agree with you more, Al. I think you're absolutely right that we ought to write this stuff down and really make sure what we're asking for and how we want it. And I couldn't say anything to that any more than I agree with you.
Yeah, I think that's how we got in the situation where we couldn't figure out what switches were where. And we had to call up there and say, where are your ECS switches? That's all I got.
Okay, how about Surgeon? You have anything?
No comment, Flight.
OSP?
Nothing.
AFD?
Yes, sir. Just a couple here. At Carnarvon, when they saw that low battery relay bus volts, I think they should have come up with some kind of recommendation, like go to 2 inverters or something, and we didn't really do anything until we got to Canton. Also, prior to retrofire, Ecom reported that the Logic and Power wasn't armed, and I think we all ought to know that you don't arm that until after retrofire. And then lastly, in the mission rules, do we really have it wrung out about going past 6-4, say, without a surge tank, with a known surge tank leak? I don't really think the mission rules are clear in this area concerning not only the surge tank, but the entry tank, and so the whole business we went through today.
Good point. And what you're pointing out is you could still have enough supply from one of the tanks that would be properly supplying the regulator, and be no reason why we shouldn't go on, even though the surge tank pressure was down.
That's a fair.
Raj.
That's all I've got, sir.
Okay. You got something you want to say, Dutch?
Yeah,
You know, one thing that breeds a lot of this extra talk going through Capcom and the crew is when we get a report of a failure, not enough data comes along with it. And then one site later we ask them if they've tried, you know, different speeds on the optics, and next time we ask them, we think of something else, has he gone down to the lower equipment bay and tried the other disk key and key release and so forth. So I think that a little bit more data with the failure reports would keep us from asking him a lot of questions.
Okay. Well, it would take a lot of time for us to tell you everything we've done.
What happens, Gus, is everybody gets out their books and starts thinking, I wonder if he's tried this and that, and then we almost have to ask you to find out what the situation really is.
Well, why don't you get out the malfunction procedures, and we're going to go right through those things.
Okay. Well, we'll assume that you're going to try everything, but before we declare a whole system like a GNN no-go, we'd like to be sure that we're doing the right thing.
Yeah, I couldn't agree more.
Well, I suspect that's going to be difficult to work out both ways. I think we'll both be looking at the thing, and when we come across something we think we should ask, we'll just have to ask it both ways.
Yeah, we don't mind.
Right, and I think that in the normal process of deciphering these things, you're going to have a little more reasonableness about it, and as Gene points out, a lot better data correlation than we've got.
Say, Chris, this is GNC again. One, I think there's a good point here that if there is a standard procedure for something like, for instance, the command module RCS thruster warm-up, when he told us that wasn't working, I think rather than us asking if he's got the prop jet logic on it, one reason I didn't do that in separate switches is if he's got the same checklist that we do on board, and maybe we just ought to ask him, have you run through that checklist completely or something like that, because he's got it there.
Roger. Okay, how about simulation?
Okay, Flight. Start with, during the launch here, there was a platform drift in the launch vehicle of about minus 0.001 degrees per second, the z-axis, minus z-axis, so Fido would have been correct on his IU being bad here. We had not anticipated the...
I guess that's what I thought too, and the question that I wasn't questioning his judgment in burning. What I was going to question was how do you promulgate that error to some error that you're going to have, because it's some finite error that you measure at that time, but you don't know what the rates are.
Flight, let me say something about that. The error that we saw right at that time, and granted, this is the first time we get to see this stuff, but it was constant, and it gets out in the flat where we can look at it. Let me say this, it might help a little bit to explain. If we had to tell you anything at that time about the booster, what Phil would have told you then, as he said, would have been it's going to be about 100 feet per second short and a little high in flight path.
Yeah, but this was a drifting error, and therefore the area you saw at that time should have been expected to be much greater when you got the cutoff.
Well, not much greater, Flight, because in 7 minutes it had only gotten this bad. And I have to assume that the rate of divergence follows some order. Okay, in 7 minutes it gets this bad. I've got 2 3/4 minutes to go. It can only get half again worse.
Well, I'm not sure I agree with that assumption. I'm not sure.
Okay, now that's we can talk.
Oh, wait a minute. Now, I'm not. What I'm saying is, I'm not so sure that the safest thing to do isn't to retrofire. I think we ought to take the safest approach.
Okay, now that's very possible, sir.
I mean, you're burning this thing and you really don't know what you've got. Whereas you can sure in hell put in a hell of a lot of delta V and get the thing down. Because you may add just enough delta V to get you an Indian Ocean impact.
Yes, sir. That's right. Now that's a consideration. There's no doubt about that. And I admit that I was not that sure of the data that I had. And I padded it. I doubled what I thought I needed based on the assumptions that I made. Now, but based on absolutely no data anywhere, then I think you may be right.
Okay, that's the reason I bring the point up.
Okay, well, I can't disagree with that.
Okay. Okay, go ahead, simulation.
Okay, Flight, associated with this problem and the loss of the RTCC, the onboard readouts here, I think the AGC was definitely no-go there, as you already know. But even when he does get a readout of the AGC and the AMS, he always winds up about 10 miles higher in perigee and apogee than what he actually is at. And I think this is a function of the AMS orbital integrator here, and they're supposed to be slaving to our integrator during this time period, and we got a 10-mile altitude difference between the two, so there is a problem in this area, and we are working toward correcting that. Another problem here, on this battery relay bus, I guess we're either confused here or maybe you're confused. The crew has a checklist that says, open up fuel cell 1 bus control circuit breaker. And all our schematics say you're supposed to lose your battery relay bus indications when you do that. And we'd just like somebody to square us away there if we're wrong. There was no problem with the battery relay bus.
Well, ECOM, we expect you to give us an answer on that. Press on, simulation.
Okay, there were a number of program errors really in the faults that we threw into the AMS. One of them was the bypass being plugged by the glycol pump. Another one is this O2 surge tank. We agree that the surge tank should read the higher of the two feed tanks here. And all we can say is it just wasn't programmed correctly here. In addition to this, we tend to think that some of the valve logic may be reversed in the AMS program. And we'll get with those people on that.
What you're saying there, I take it is, as I understood previously, that when you turn this cutoff valve, that has an effect on the surge tank in the opposite direction.
That's affirmative.
Right, I see.
Okay, and we think this is just programming errors, and we'll look into it. The battery charger problem is another problem that is inherent in the AMS, and you'll probably note it for the rest of the sims that we run here. There's not much we can do about correcting it. Another problem associated with the launch phase here that's not a spacecraft problem, we have received a large number of RTC executes coming out of CCATs during the launch phase, and we're just wondering if you people were sending all those things or what's going on.
Any input there, network?
Stand by, flight, we'll see. There should have been at least 2. ECOM sent 2, but we coordinated those, and they were in fact received, and there was one booster command, but there were a number of other commands coming out, and I don't know whether the network's aware of that or not.
Sim from booster, we normally wouldn't initiate a command during launch phase. We're locked out by our own decoder.
Well, somebody did. Or we have a printout over here, over at our computer, and we have a printout of all these things coming in on the line, so I don't know what's going on there.
Are you talking about loading a site or actually initiating a command?
I mean initiating, executes.
Uh-huh.
Okay, GNC's already covered this helium manifold leak, and that was in fact what it was. There was a leak between the regulator and the check valve associated with quad A here. And I think that's about all that we can explain right now. I have an AMS IP, which turned out to be 31.17 north and 144.6 west.
Okay, what are we going to do for the rest of the day here, simulation? Have we got any input from anybody?
That's affirmative. We're going to come up ready to run again right now, I guess.
Is that what
the crew will do whatever you wish here, was the last word I had.
That's right, we're ready to rock.
Okay, what do you want to do? You want to run a normal launch insertion? Okay. All right, Econ. Okay, let's press on. We're ready to go when you are.
Okay, we'll get in.
Say, flight. Say, Roger.
Yep. I can't find in this checklist I have where you guys ever open the fuel cell control circuit breakers.
Are you talking to Sam?
On gas 3.
Mine either.
That would cause us to lose our telemetry of that of the battery relay bus, but I sure can't find it in the checklist where you ever do it.
The bus control circuit.
Simulation booster on gas 3.
You're talking about fuel cell bus control?
Right, fuel cell 1 bus control.
Yeah, no, we didn't pull it. As far as I know, I'll check when we climb back in, unless it was an inadvertent actuation of it. Now, we do pull the H2 and O2 valve.
Yeah, right.
Okay.
Stop.
Hey, Apollo 1 Houston. Apollo 1 Houston. Houston, Apollo 1. Apollo 1. Hello, Houston, Apollo 1. Apollo 1 Houston, go ahead. Roger, we're standing by anytime you're ready to go. Sure will, and do you have the pad message on board already? Negative, we haven't received that yet. Roger, wait one, I'll see if the one I've got is the one to pass. Hold. Right. Apollo 1 Houston, if you're ready to copy, I'll give you through area 4-4A when you're ready to copy, starting with area 1 BC. Stand by 1. Roger, you're on call for block update now. Roger. Ready to go. 001 BC minus 1570 plus 05500 0002611 500 NA and NA 002 1A plus 3122 minus 06537 001 3028 425 001 0538 100 003 1A plus 2695 minus 06673 003 0322 429 002 4124 100 004 4A plus 3132 minus 15625 005 4806 347 005 2446 100. Normally we'd pass all the way through 008, but for the purposes of simulation, I'll just pass through 4. Roger, be advised your format doesn't seem to agree with mine. Would you go down and check it? I'll start reading it out to the area. Target latitude, target longitude, EPI, then you start in there hours, minutes, seconds, EVA, EPI, minimum, hours, minutes, seconds, and then EVA. Houston, Apollo 1.
Apollo 1 Houston, wait 1, please.
Go ahead. I failed to get the power on. Okay, we're good.
Apollo 1 Houston, it appears that you're correct that our format does not agree with yours specifically because we've not been reading you the seconds, or correction, that GETI, the SPS burn in seconds to the nearest 100th of a second. And we'll modify that, and for purposes of the readout I just gave you, all those tenths and hundredths of a second position should be 00.
Okay, when they come through like that, they toss you after that and, on the first readout. And another thing that you ought to do, we probably ought to modify our voice procedure so that you read each time, start with a new area by saying area 001, BC, etc., and then go down to the code, then go to the next area.
All right.
And your speed on those is just a little too fast.
Okay. Do you want us to have another go at it?
Let's try it again, and can you modify yours to read up the correct section?
Say the last part.
Can you modify your format so it comes up in ours?
Sure can. I'll do it right now. We won't do this wrong again.
Okay, let's try it out.
And by the way, we're still at 10 minutes and holding, and when we start counting, I'll let you know.
Roger, and I'll be standing by for your
Roger. Okay, area 001 BC minus 1570 plus 05500 000 6 1100 500 NA 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 area 002 1A plus 3122 minus 06537 001 30 2800 425 001 05 3800 100 WEX is NA 003-1A area plus 2695 minus 06673 003 2200 429 002 41 2400 100 NA. We might want to, by the way, we might want to modify these farms because we never give you any weather on these.
That's fine. We're not looking for it.
Okay. Now it's area 004 4A plus 3132 minus 15625 005 48 0600 347 005 24 4600 100 NA.
Apollo 1 Houston, did you copy?
Roger, ready for the readback?
Roger, and for your information, we're at 9 minutes, 11 seconds counting. I'll give you a mark at 9 minutes. Stand by. Roger, we're holding at 9 minutes, so I'll go ahead and read back.
Roger, read back. Area 001 BC minus 1570 plus 05500 00026 1100 500 NA 002 area 002 1A plus 3122 minus 06537 001 30 2800 425 001 05 3800 100 area 0031A plus 2695 minus 06673 003 03 2200 429 002 41 2400 100 area 00448 plus 3132 minus 15625 005 48 0600 347 005 24 4600 100.
Apollo 1 Houston, that's correct. We've recycled to T-minus 10 minutes, and we're holding. Okay. Apollo 1 Houston, is your up-tail switch in the accept position? Apollo 1 Houston.
Go ahead.
Is your up-tail switch in the accept position?
Affirmative.
Roger.
RKV, AFD on Gus Prime.
AFD, RKV.
Roger, we expect to pick up the count in 5 minutes.
Roger, at what time in the count?
Minus 10 minutes.
Okay.
Can I have an AFD, you copy?
That's firm.
Roger.
Apollo 1 Houston, we're presently about 8 minutes and 30 seconds counting. I'll give you a mark at 8 minutes.
Right.
Two, one, mark. 8 minutes.
Go in our office. Get in right on here. Yeah, he's right here right now. Coming that way. Okay.
Apollo 1 Houston, stand by for a 3-minute mark in 10 seconds.
Roger.
2, 1, mark. 3 minutes. Stand by for a T-minus 1 plus 15 hack in 5 seconds. One, mark. T-minus 1 plus 15.
IOS. Go ahead. You know our computer's still on it? Rise in about 5 seconds. It'll run.
Mark, 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Lift off.
Clock started.
liftoff 170000.
Roll is complete.
Houston, roger. Mark, 50 seconds.
Roger. We have no auto board indications.
Roger.
Houston, Apollo 1, 2 engine out is off, launch signal race is off.
Roger.
EDS auto is off also.
Roger. Mark, mode 1C.
Roger, 1C.
Apollo 1, you are go for staging.
Roger.
Apollo 1, you go for tower jet.
Entry outboard. For thrust.
K2 is go. Roger, tower jet, O2. Apollo 1, Houston, place battery C on the line, please.
And we've lost battery A bus.
Roger, battery A bus lost. Apollo 1, Houston, guidance initiate, and it looks good. Houston, roger, and understand your previous comments. Apollo 1, Houston, your water boiler is go, and your trajectory looks good.
On the onboard guidance is go.
Roger, onboard items, go.
Still go.
Roger, and you look real good from here. Apollo 1, Houston, roger, you're very weak. Apollo 1, Houston, your booster looks real good.
Roger.
Apollo 1, we show PMR on, and your GNN is go.
Roger, the onboard guidance is go.
Hit remote.
The mood is remote. Let's go.
Roger. Apollo 1, Houston, you're go.
Roger.
Mark, mode 4, and you are go, Apollo 1.
Roger, mode 4.
KVS 10, solid. Apollo 1, Houston, you are go.
Roger, we have show a perigee of 80.7 miles.
Roger, 87.
807.
Roger, 807. Roger, and your S4B is safe, Apollo 1.
We show a apogee of 115.7 and a perigee of 80.8.
Roger, 115.7 and 80.8. Venting is proceeding normally, and your GNN looks go.
Roger.
Flight RKV. Flight RKV.
Go ahead.
We're reading 0 volts on bat bus A and B and battery relay bus.
Roger, we think we got a TM problem there. We think it's okay, and we'll worry about that shortly.
Roger.
We saw that also.
Roger.
The logic A and B are okay, and the ECOM here thinks that we've got a bad TM.
Roger.
We did, however, during the launch phase, have him put battery C on the line.
Roger, we copied.
RKV Houston, go remote.
RKV remote.
Apollo 1 Houston, we show your perigee 78.9, your apogee 115.2.
Roger.
We're taking a look at your logic, battery, and relay buses at this time.
Roger.
Houston, Apollo 1, we have no readings for bat bus A or B, and the bat A power entry and bat B power entry circuit breakers are both open. We are not able to reset them.
Understand. Apollo 1 Houston, we'd like you to leave both inverters 1 and 2 on the line. Over.
Roger.
You received
Both on, we'll stay there.
load for
Roger.
Judah and Carnarvon, 4501, 4701, 4801, 5001.
RKV Houston flight.
Flight RKV.
Do you hear that report?
4501.
Roger, we copied most of it.
Okay, battery A, the A and B bus reads 0, and his circuit breakers are popped, and he's unable to reset those on those buses. We've informed him to leave the inverters 1 and 2 on the line since we can't read a battery relay bus.
Roger.
Okay.
RKV has LOS.
Has acquisition.
Canary, go remote.
Canary remote.
Apollo 1 Houston.
Roger.
Roger, the timing in the S4B is accurate, and sequences 1 and 2 will come off as scheduled. Over.
All right.
Apollo 1 Houston, could you confirm that the 2 circuit breakers that are popped and cannot be reset are battery A and B power entry circuit breakers?
That is affirmative.
Roger. Apollo 1 Houston.
Roger.
Roger, our ground indications show that you have probably lost logic buses A and B and battery buses A and B. And we're about 1 minute to LOS now, Canary Islands. We'll pick you up over Banana Reef, but it looks like now we may ask you to power down over there and try to isolate this electrical problem. We'll give you more information over Banana Reef.
Roger. Has LOS. $36.49.
Carnarvon Capcom Houston flight.
Houston flight, Carnarvon, go.
We've lost both our battery buses A and B, and he has tried the circuit breakers and cannot get them back online. If this situation can't be improved, we're going to bring him into 2-1. We're going to give him a list of circuit breakers to take the various sources of power off the line to check to see if we can get the A and B buses back. We're going to ask him to do that between Tananarive and Carnarvon. When he comes up on your site, give us a status. If he can't get those back, what we want to do is go ahead with a no-go and a re-entry into 2-1, and it looks like it'll have to be an RCS re-entry.
Roger, flight, copy.
Roger.
Reeve has acquisition.
Tananarive, go remote.
Tananarive remote.
Follow 1, Houston. Go ahead, Houston. Roger, we've taken a further look at your electrical situation. It kind of appears to us right now that if we're not able to improve the situation, we're going to have to think about an entry into 2-1A. And of course, this would have to be a service module RCS entry. We'd like to go over a few circuit breakers with you and perhaps try to isolate battery bus A. Have you got a list on board of all the circuit breakers that provide power from battery bus A to different components?
That's affirmative.
Roger, have you gone through this list, removed the components from the bus, and then tried to reset the blown circuit breakers?
That's affirmative. We removed all of them that are shown in our schematics and malfunction procedures.
Roger, what we'd like to do is... Did they reset the circuit breakers? Were you able to reset the circuit breakers then?
Negative.
Roger, we'd like to just verify with you then a list of these circuit breakers. And if you're ready with your list, I'll read my list and we can compare them.
Let's go.
Roger, I've got main bus A. Flight and post-landing bus circuit breaker.
Say again now the name of the circuit breaker.
The first one was main bus A circuit breaker.
Okay, you mean main A, bat bus A, the one that ties the two buses together?
Roger, that's the motor switch.
Okay, we've got it.
Roger, flight and post-landing bus circuit breaker.
It's pulled.
Battery relay bus circuit breaker.
It's pulled.
Battery charger switch and battery bus A tie switch circuit breaker.
They're both pulled.
Roger. How about EDS bus 1 circuit breaker?
EDS bus 1 circuit breaker is open.
MESC arm A circuit breaker.
It's open.
Gimbal motor control pitch 1 circuit breaker.
It's open.
Gimbal motor control yaw 1 circuit breaker.
Open.
ELS logic and float bag number 2 control circuit breaker.
It's open.
Compressor number 1 uprighting system circuit breaker. Open. Roger. Now the only one that I didn't call out was MESC logic A circuit breaker because that provides the power so you can read the instrumentation, the voltage on the bus. If you removed all the others and it still will not reset, you might remove that one and try resetting.
We'll try it once more now.
Roger. And I'd like to now give you the information for battery bus B. Stand by.
Okay, we've tried it on battery A, power A. It will not stay in.
Roger, can you do any good by holding it in?
That's a negative. These circuit breakers are built so you can't override them and hold them in.
Roger, I'd like to run. We've only got about 2.5 minutes to LOS. I'd like to run rapidly through the battery bus B circuit breakers also.
It'd be simultaneously with A. We've checked them both.
Okay. Apollo 1, apparently we can't seem to solve this problem, and it looks like we'd like you to do a early separation from the S4B at 1 plus 05, and then we're planning to give you your reentry information over Carnarvon. Hey, we like to do an early separation because we think the failure is tied in with the ETS system because it started failing early in the flight at about the time we lost the circuit breaker. So we like to get off the S4B and see if that improves the situation. Roger, you got to go to do that, and we'd like to know what the configuration of your main bus tie switches is at this time. Both off. Roger, we'll proceed to separate at this time. Roger, please record your time of separation, velocity, and attitudes.
Ready, Tom.
We don't have any power to separate with. Roger, understand no power to separate with? That's how the logic does it. Let me try the battery. Apollo 1 in Houston, only suggestion is this time is to try the battery charger on battery bus A and separate as soon as possible then. The battery charger is sick and bent. Roger, understand battery charger is down. Apollo 1, Houston, our next suggestion is to try to apply one of the pyro batteries to one of the main buses and separate that way.
Now, Revas, LOS.
Carnarvon, Houston flight.
Go ahead, flight.
I'd like to have Ecom here tell you what we'd like to do since he doesn't have any separation capability. We're going to try to put one of the pyro batteries on one of the battery buses to see if we can get enough power to separate. Would you go ahead, Ecom?
Okay, Carnarvon, what we want to do, we want to use pyro battery A to attempt to put voltage on entry on battery bus A. Let me say it again. Pyro battery A on battery bus A. And we'll have to do that by closing pyro A, bat A.
Break, slow down one. Okay, close one.
Pyro A, bat A to pyro A bus tie. That's circuit breaker 15, LEB 150.
Okay.
Okay. Let me emphasize. We want all loads removed from that battery bus. He should be in that configuration when he comes over the hill. He has already done that, and I'm confident that's the configuration he'll be in when he comes over, but you ought to check and make sure before he closes that switch.
Okay, let's go over this one more time now. Pyro battery A on battery bus A, okay?
Roger.
All right, close Pyro A, battery A, to, I didn't copy the next.
Pyro A, bat A to pyro A bus tie. And that's going to put pyro battery A on the battery bus A. You want to verify that pyro A, sequence A, circuit breaker 14 is closed.
All right, repeat that one. Confirm.
You'll want to confirm that circuit breaker 14, which is pyro A, sequence A, circuit breaker is closed, and that's in LEB 150. Okay, and he will also need to close master event sequence control logic A, bat A.
Break, slow down. Close master event sequence control.
Logic A, bat A, MDC 22. That's a circuit breaker.
Okay. Let me read back to you. Okay, you want to put the Pyro battery A on battery bus A. Okay, to do this, you close Pyro A, battery A, to Pyro A, bus tie. Okay? You want to check the circuit breaker, CB15 in lower equipment bay, 150 to be on, right?
He's talking with flight right now. You'll have to wait one.
All right.
Okay, go ahead.
Okay, I'd like to confirm this back with you.
Okay.
Pyro battery A on battery bus A.
Roger.
Pyro A bat A to Pyro A. Bus tie.
Say it again. Pyro A, bat A to Pyro A, bus tie. Right.
Okay, confirm CB15 lower equipment bay 150 to be closed.
Roger.
Confirm CB14 Pyro A sequence A is closed.
Roger.
That's lower equipment bay 150.
Roger.
Okay.
Okay, and the other one I gave you is going to allow him to arm his logic from the battery bus A.
Capcom. Did you give him the name of the first circuit breaker in 150 lower equipment bay? He called out the number, but I don't know if he got the name, and they want the name. Okay.
Okay, and confirm that CB14 on Pyro A, sequence A is closed, lower equipment bay 150.
Roger.
Okay.
Roger.
Confirm all loads removed from that bus, right?
From the battery bus A. That's with one exception. And that is circuit breaker 21 on MDC 22. And that allows him to power the logic bus. That's master event sequence control logic A, bat A.
Okay, that's CB21 from MDC
Roger.
21.
Roger, and then he'll have to do his regular arming routine to power his logic and pyro.
Houston flight.
Go ahead, flight.
We want to make sure that when he goes through all this positioning of the circuit breakers and switches, that he's prepared to do a separation ASAP as he does that. Okay?
Roger. All right, do I have any loads to give you, flight?
We are trying to get you an RCS update.
All right, you want to pass up the Verb 76. Is that affirm?
That's affirmative. Stand by. Houston flight, you should have a nav load. Do you have it?
I've got a nav load, flight.
Okay, and we're working on an M3 update.
Okay, fine.
Carnarvon, Houston flight, we'd like to also know the battery C voltage and whether he has that online or not.
Carnarvon has AOS. Apollo 1, Carnarvon. Apollo 1, Carnarvon. Apollo 1, Carnarvon.
Carnarvon, Apollo 1.
Roger, how you doing on your SIP?
We've separated. We put in 3 feet per second. And the way we separated, we went counterclockwise on the abort handle, and Ed jammed the circuit breakers in, and we separated just with that mic.
Roger.
Do you still have a GNN?
You still have a GNN system? Apollo 1.
We apparently still have a CNN system.
Okay, I have a Verb 76
Flight, we still need to know about battery C. He's going to have to get battery C on the main buses before he separates.
Apollo 1, can you give me your battery C voltage, and is it online?
Battery C voltage is 37 volts. It is not, well, it's on the line, yes, but it's not tied to the main bus.
Roger, copy. You copy, flight 37 voltage, not on the bus.
Go ahead with Verb 76 update.
Roger. 001090000. 65455. 64463. 05517. 26372. 74130. 45.
Carnarvon Systems, Houston flight.
65255.
Carnarvon Systems, Houston flight.
15. 61665. 40230. 10255. 34176. 00031.
Carnarvon Houston flight. Break, will you? Carnarvon Houston flight. Carnarvon Houston flight.
Go ahead, flight.
What are you giving him at this time?
This is the nav update.
That's not going to do him any good if he doesn't have any GNN. Do you have the deorbit update coming to you?
That's negative, flight.
Okay, it should be on the wire. I'll start reading it to you if you can get it to him.
Roger.
Stand by. Apollo 1.
Go ahead, Apollo 1.
Roger, you'll have to start over with the update you're going to pass me.
Roger.
Carnarvon, we'll remote through your site. Give us remote. Carnarvon, go remote.
Carnarvon, remote.
We don't know where it is. Apollo 1, Houston. Go ahead with your update anytime. Apollo 1, Houston, do you read me? What? Carnarvon, do you have that message yet? Apollo 1,
That's negative.
Houston. 1750 Zulu. Apollo 1, Houston. Go ahead, Houston. Roger, we're ready to give you that deorbit update now. Area. This will be an RCS S4B deorbit update. Area 0021A. Plus 3122. Minus 06537. 130. 001 10 42 00 003 295 001 039 25734 360 0530. All the rest are NA. Roger, SIG in the area. That's area 0021A. Roger, ready for the readback? That's firm. 0021A plus 3122 minus 06537.
Give us a reading
130
of the source pressures on the command.
001 10 4200 003 295 001 039 25734 360 0530. Rest on that.
Roger.
Houston? Houston, Apollo 1.
Apollo 1, Houston, your readback was correct. We'd like to verify at this time that you have the capability of putting battery C on the line just before separation.
Roger, but where we stand right now, we have no way to get our chutes out. If you were interested.
You'll have to use the same routine that you used before for all logic functions. Over.
Marvin said LOS.
Marvin, Houston flight.
Go ahead, flight.
Did you see anything else in your path?
No, all other systems look good, flight, except the battery problem.
And the RCS wing B. You confirm we got no RCS wing B.
That's affirmative, flight. We
Right.
confirm that.
Three, two, one, retro fire.
Canton has acquisition.
Canton, go remote.
Canton is remote.
Apollo 1, Houston.
Go ahead.
Roger, are you performing your RCS deorbit maneuver at this time?
Negative.
Roger, have you completed it?
I'm not going to re-enter when I can't get my chutes out.
Roger, wait one. Apollo 1, Houston, we were wondering if you had considered the periodic use of your pyro battery to the battery bus to perform logic functions whenever you needed it, for example, deployment of chutes, over.
We've considered getting some information on the lines and cutting out of the box and wiring around the circuit breakers, but we're not going to try the other yet. We better think about it a while, make sure we know what we're going to do before we try it. If we re-enter, that's our last chance.
You got a point, Apollo 1.
Yeah, I think we probably do.
Apollo 1, Houston flight.
Go ahead, flight.
We'll see you tomorrow morning.
Okay. The computer's it's bombed out anyway. I guess you know.
Yeah, we do that. We tried, how about getting out and getting on God's conference, and then we'll talk to you so you'll be a little more comfortable.
Fine, just go ahead and talk.
Okay. Let me get everybody in the control center on air to ground.
Flight, I can switch the crew station over to God's conference if you want.
Okay, do that, would you please?
You're on God's conference?
Yeah, I'm on God's conference. You on, Gus?
Yep.
Okay, you're coming in broken here. Can you read me?
Well, we'll go down to the instructor's console. It'll take us about a minute.
Okay, standing by. Slide, you want to turn this equipment loose or you want to hold it up past our cutoff time? Roger.
Temp core. Whoops.
Okay, Chris? Yeah, Gus. Are you ready?
Ready.
Okay. All I got to say is that's a hell of a thing to do to us when we're hungry and tired. However, let's see, during the, I'll go back to the launch here, see if we can cite something out there. I got a report from ECOM just after Mode 1C that one battery was out, and he wanted to put battery C on the line. I didn't do anything about it at that time, figuring that we'd wait till after we got staging. Right after staging, and we got Tower Jet reported, we asked you to put the battery C on the line, which you did, and we noted that the A bus had failed. From then on in, everything looked okay. We did have some concern that we were going to be short on propellants, but it turned out that we were not. We did have an analysis from the backroom people. I take it through FIDO that the IU analysis showed the launch vehicle was going to be high and fast, which didn't turn out to be the case either. The ECOM was also interested in finding out about the battery bus motor switch being open. He can talk a little bit about that later. I'm not sure I understand all of what's going on here, by the way, not by a long shot. After we got a go condition, the ECOM reported that the logic A and B were okay, and that the A and B feed buses showed we had bad telemetry. Now, I guess that may have been a bad indication because that later turned out to be the problem we had. Then we got a report from the crew that the A and B buses were zero. They had no A and B battery buses, and that the circuit breaker, they were unable to reset the circuit breakers. And at that time, we told the crew to leave both inverters 1 and 2 on the line, and you rogered that. And from then on, we tried to go through all this business of what we could do about getting the circuit breakers that control all of the other power off the line, so that you could attempt to get those buses back. Obviously, that didn't work. Now, we also tried to get to you the use of the pyro batteries on the main A and B logic buses. That is, by momentarily putting the pyro batteries onto that line. Evidently, you didn't receive that transmission from Tenanenreeve, and we got the report from you after we got through Tenanenreeve and up on Carnarvon that you had separated by holding the circuit breakers in. We thought, though, that you still understood that we wanted to try using the pyro buses, or the pyro batteries, to power the logic buses so you could get some of these functions to occur. Either you didn't understand that or you don't agree with it, and I guess you can tell us a little bit more about that.
But I did receive that, Chris.
I see. Well, I guess we were under the impression that you had received that message. Okay, let me press on a little bit here. Right, that's what happened. We were, we got bollocksed up there ourselves. We recognized that you hadn't received that at Tenanenreeve. We had given that to Carnarvon, and I guess we had to take over from Carnarvon, and we did not get that message to you in trying to get the RCS reentry update to you. So I can see where you probably didn't get the message. Okay, we also noted, by the way, over Carnarvon that the ring B source pressure was down, and we were also going to give you the information over Canton to that was so that you would have to use only ring A, and that if you ran out of fuel in ring A, we would have recommended that you try to manifold the B, the source pressure from A into the B system to try to get some more fuel out of the B ring. We were also going to give you the word that we wanted you to stay tied on to the service module as long as possible in order to utilize the fuel cell power ASA as long as you could, and we were going to give you a time that we thought you should separate after retrofire of about 19 minutes. We were also going to look at the possibilities here of a command module RCS reentry if we had not been able to separate from the S4B. But since we did have that case, and we'd have been in bad shape anyway since we'd lost ring B source pressure. Okay, I think the next place to talk, Gus, is to listen to you, and then we'll get the ECOM on the loop here.
Well, we lost the EDS system early in the flight, and so we thought that's where the short was in there someplace, and we tried to isolate that first, and do just about everything that you'd call up, I guess, maybe one or two exceptions that you caught that we'd missed. And I don't know if anybody else has anything to add on that or not, but I did think that we ought to be re-entering right away when we weren't assured that we could get a shootout. So I don't think I would have done that.
Okay, I guess we can't argue that point. And we would have, I'm sure if you had decided against it, we'd have gone around and set you up again for a retro fire in the next orbit after we talked over this pyro bus business. I believe it's our opinion that in this case we would be very concerned that you would have any kind of power left after a while with all these things dropping off the line. I guess that's the reason the mission rule says we try to re-enter ASAP.
Well, the battery charger or anything, why, how'd it gone along with it? The way we were, we didn't stand much of a chance of getting a shootout at all, so...
Hey, Gus, this is Econ. Did you have any ideas on using the pyro batteries for these logic functions as Flight had indicated? Do you disagree with that philosophy?
Flight, I think somebody pulled the patch. Are you back, Gus? Anybody on the line at the Cape? Flight, this is Sim. We lost all the lines going to the Cape. Okay. Network, can you check on that for us?
Houston Simulation, AMS on Goddard Conference.
Okay, we read you loud and clear now. Put the flight crew back on.
Okay, we're here.
Hey, okay, Gus. I guess we'd like to hear your feelings on using the pyro bus.
We've been cut off here for a long time. We still don't know what the procedure is to use it.
Gus is Econ.
Go ahead.
What we were recommending that you do was to power the battery bus A from pyro bus A periodically as you needed logic functions. This would be in the entry phase.
Could this be by putting the Pyro A main bus IA circuit breaker in down on panel 150?
Roger. You'd have to use your bus ties there, yeah.
Yeah, but the thing that bothers me about, we didn't have a battery failure. We blew the circuit breakers.
Roger.
The battery bus is going to blow the circuit breakers and connected the main batteries to it. Why wouldn't it blow these circuit breakers when we tie the pyro batteries to it?
We wanted to make sure there that you had everything else off the line and you were just using that one circuit breaker.
Yeah, we did that, and the procedure they read up over the radio, we completely isolated the battery bus so that nothing was on the battery bus at all. And we punched the circuit breakers in, and it still disconnected the battery from the bus.
The way we looked at that was it was the only hope.
Now, we think we accomplished separation, essentially doing what you said there, except we just used batteries. We set up for separation and then punched the main batteries in to spike the bus. And we did get the sound of the pyrotechnics firing and a real short separation signal. But we did it with the main batteries rather than with the pyro batteries. I guess we didn't want to go in with having somebody punch circuit breakers in right away during re-entry when the chutes were...
Okay, well, we were on the impression that you couldn't override those circuit breakers like that. If you could do that, wouldn't we want to do that for the entry phase as well?
Yeah, you can't. They won't stay in, but when you push them in to reset them, they momentarily don't make a circuit, and then they blow again. The bad part about doing it during the entry phase is they're on the floor of the lower equipment.
Good point.
Yeah, I understand that, but how about this pyro bus thing?
They're the same space. They're all on the same box.
In other words, in order to put the pyro battery on the main Logic A bus, you would have had to be in the equipment bay?
That's affirmative.
This is a pretty well-packed cockpit.
Well, I guess you'd have to try to do that if you didn't have any other way to get down.
Yeah, I agree. I sort of think that if it had really happened that way, we would have cut into that pyro box and wired around those circuit breakers.
Raj.
I would have tried that first, I think.
Well, I'm not arguing with your refusal to do the retrofire without some reasonable means of trying to get the chutes out. I agree with you.
And this other way is it's just a spike, and you might or you might not get your circuit breakers. Both of them are sort of a spike, I guess. Oh, hell, I don't know. Let's don't have that failure.
I'll buy that one. Okay, does anybody else have anything here to say? I guess we got all that business worked out on the RCS okay.
Flight, this is Carnarvon.
Go ahead.
Okay, my understanding was, I was in error in it, on this procedure, that when he got separation, I failed to give him this pyro battery procedure, tying it into battery bus A. Okay, then Gus, didn't you say that you had a good GNN system? That's what I understood.
Yeah, we thought it was good.
Okay, then I agree I read this thing up, but did you want to go ahead and uplink the Verb 76 load to him that we had on station?
Yeah, we wanted to do that by DCS.
Okay, but in our backup, Chris, are we reading the octal after we give the DCS? On the Verb 76?
No, I think we discussed that the other day at a meeting you weren't at. We recognized that when we got to the 2-1 case,
we were going to have so much to do at Carnarvon that we would not be able to read it up, and they just have to take the DCS load.
Okay, I didn't have that word, Chris, on that one. And I was waiting on the deorbit load, the pad, to come in, which, by the way, got in here about 8 minutes after our acquisition.
Understand.
LOS.
Well, I think what we should have done there from the beginning was take over remotely from here, since we had all the information we wanted to pass anyway, and I should have broken in much sooner and had our Capcom take over.
All right. I've got a question, Chris. On that Verb 76, let's say we do send it via the DCS, was that Verb 76 good for orbital conditions after the separation? Was that calculated after SEP?
Roger, flight, that's right.
Yeah, but that was calculated on the basis of a normal separation at 1 minute and 5 seconds. You are right that the ephemeris that we had for that nav load was incorrect, but it was not so incorrect that it would have been okay.
Okay, and I have one other comment concerning the ECOM's relay of the circuit breakers. I think it'd be a good idea when we're critical like this, and you're going through these circuit breakers with these, well, very long names and so forth. If ECOM would just reference this to the page number in the system's handbook, 221, you can very easily identify the route he was trying to establish, and we could have used that on site as a basis for reading it to the crew and had it exactly correct.
Roger. We should have done the same thing with you that we did do with the crew.
Okay. That costs us a lot of time for just
right.
an acquisition.
Right, understand.
Flight, this is Retro.
Go ahead.
I'd like to ask the crew if they understood the entry procedure we wanted them to fly of lift vector down to 210 Gs and then roll for this type of re-entry. Are you aware of that, Gus?
Yes, we understood it, but yes.
Okay, lift vector down 210 and then roll.
Right.
Right, that's the same way we were thinking about doing this command module RCS re-entry, Gus.
Roger. That's what I'm doing.
Right, okay. Okay, I'm ready to give up. How about you, simulation?
Okay, flight is, as far as the booster and flight dynamics area was concerned, the launch phase was identical to that one on the first run there, so that's what it would have looked like. This whole thing boiled down to a matter of our trying to fail the batteries, and the only way we could do that was to pop these circuit breakers on him. And we popped the first one at 40 seconds at liftoff, and we were trying to get the second one in around 9:20 or so to get you into a 1B area, or 1 Bravo area, or something of that type. You didn't take the bait there. I think possibly we misled ECOM in the fact that our program didn't really drop the logic bus readings immediately, and I'm not sure whether we got those things manually dropped before LOS or not. I don't think we did. And so he didn't really believe that the batteries were going there to start, and therefore didn't abort the thing.
Yeah, well, if you recall, I went over that he reported at first we had bad telemetry, and then I guess you failed. What you did was give him another failure after that sequence.
Right. What happened is the program fault didn't drop all the telemetry that was related that should have been dropped.
I see.
And anyhow, after we got into orbit, we had to play the things with short here, and that is in fact the way we had to play it. We wound up with 2 shorts there on the buses. The RCS command module, ring B, was leaked out at 32 minutes, and those are the only problems we had in the...
that was enough.
The AMS, of course, and the GFSC had program stops at about 56 minutes, and we couldn't recover from them.
Raj. Yeah, I guess we went over this one the other day, Gus, and we were considering the fact of whether we should have a Mode 2 abort or go into orbit under these conditions. How do you feel about that?
I think I'd rather go into orbit. Because if we're going to have to get down in the equipment bay, we're going to have a little time to get up and get ready for it. You know, and be able to stay there during, we have to stay there during the whole re-entry.
Well, I guess that's, we didn't think of that, as a matter of fact, but we did consider that under these circumstances we'd rather go into orbit and then try to do something about it.
Yeah, I think I'd rather go have a little time to think about it. Give us more time for memorial services anyway.
Yeah, okay, well, I think let's everybody mark that one down, and we'll talk that one over a little bit more when we can see you face to face.
Okay.
Okay, When do we meet with the crew again, on Monday? Is that right?
That's fair enough, Flag.
Okay. We'll see you again on Monday in a simulation, Gus.
Yeah, what's liftoff Monday?
1300 Zulu.
Okay.
Okay, sure appreciate it.
Okay, see ya.
Thank you.
Flight, Carnarvon.
Go ahead.
I'd like to speak to procedures and retro or guidance when you get through.
Okay. I got one announcement that might be of interest to people for tomorrow. There's an experiments briefing that will be tomorrow at 9:30 in room 547, building 45. 204 experiments. Go ahead, Carnarvon.
Okay, Larry, is retro and guidance there? Look,
Yeah, I'm here.
okay, John, on the pad messages when we got them coming out late, you know they're going to be late.
That was our fault.
No, well, stand by. I think we can get around. Here's the problem was we have all this darn traffic coming over here, and we got to checking it, and your ACK messages and all this jazz is coming out special.
We should have gone UU.
I was just thinking to say, I think we ought to use UU in these cases.
We got it so fast, and Cannon stuffed it in a tube before anybody even knew what was going on there.
Okay, Larry.
We're just trying to get it out, and we were late getting it and a little late getting it cut.
Oh, it should have been special.
Yeah, well, it should have been higher than that, John. It should have been UU and interrupted all this other message, this other data we're getting out here.
We should have caught that up here, Chuck.
Chuck, it was our mistake for not getting it there early. We should have had it there earlier.
Yeah, but I want to. What are you trying to say, John?
About acquisition time, John, had we used a UU because we had grant.
Yeah, I understand what you said, but we should never do that to you guys.
John?
Yeah.
Stu. Do you have any other changes to the update?
No, Stu, what the problem is, we decided right off that if we're going to, the problem is that, let me tell you what happened. We have run some command tests here, and we are really happy with the way the command system is and how you can check the numbers in the state buffer. Okay?
Yeah, I think we both agree to that.
Okay, now, the point here we said is there's so damn much data to pass up that for a 2-1 case, okay?
Okay.
For a 2-1 case, that what you do is you send a command and you can see the octal words, and that's it. That's all he's going to check. And before you enter, or before he enters them, you're saying to yourself, and it won't take you but 4 seconds to look at them, and then you say they're good, and you shift them in.
Right. To send the enter, John, or you want the crew to send the enter?
Well, that hasn't been decided yet, but it seems like you guys to me that we're sending the enter.
Yeah, okay.
Guidance is on here. He looks like he's agreeing with me.
Okay.
Okay, and that's what we're going to talk to him Saturday about on that one case.
Okay, that was my error.
Because they don't buy any more that way. No, but the point, the thing was that we did not know, and I didn't know, that we were not going to do a GNN burn.
Shocked us too.
Okay, now that's the thing, that we would have never sent you the goddamn thing out there if we knew that.
Well,
we were going GNN, and we always try to go, and nobody had told us until the time the flight director came up in there and told him his AGC was no-go.
Oh, that's the thing. The crew reported to us that GNN was good, and we
were still going GNN. We'd never sent it out there. We'd never sent all that jazz with it if we were not going GNN.
Well, I asked, and I got the word that it was go. And that's
okay, babe. That's it. We'll have to get that straight in house here. We had 20 minutes to go at that time, and we could have gone through it.
I think so.
Okay. So that's partly our fault. We should be sending you nav loads if we're not going GNN, and you'll never get one, by the way, if we have.
Something that always confused me. It did on the other SIM was your Verb 76. Now I made a point earlier. When you sent out a Verb 76, like on a 2-1, where we might step at Carnarvon or earlier, would you flag it as being good post-SEP, normal SEP, or something like it in the remarks section?
The only one you're going to get, it's only 76 that you're going to get, is the one that includes the normal SEP burn. If they come off that early like they did today, we can't control that.
I know, that's right. Okay.
But every time, that's what I said, every time you get, the only nav vector you get at Carnarvon, and I think Guidance agrees with me on this one too, is the one with a SEP maneuver in it. Okay? And if they've already SEP'd, of course it's okay, but if you get one, it's with a SEP maneuver in it.
Okay, now if we run into a case like we had today, like Chris said, it's close enough, we'll go with it, right?
Yeah, we wouldn't have stopped you.
Look, what you did was done right, because we would have never sent it if we didn't think we were coming in G&N, babe.
Okay, I just want to make sure that what he said was okay. Is the premise is close enough to go ahead and use it, regardless of the SEP?
Yeah, but the SEP is usually based on nominal time.
Gotcha.
Okay, it will be the right number. It will be the only right thing that you got out there.
Okay.
Never sent you the goddamn thing out there if we knew that.
Well,
we were going G&N, and we always try to go, and nobody had told us until the time the flight director came up in there and told him his AGC was no-go.
Oh, that's the thing. The crew reported to us that G&N was good, and we
were still going G&N. We'd never sent it out there. We'd never sent all that jazz with it if we were not going G&N.
Well, I asked, and I got the word that it was go. And that's...
Okay, babe, that's it. We'll have to get that straight in-house here. We had 20 minutes to go at that time, and we could have gone through it.
I think so.
Okay. So that's partly our fault. We should be sending you nav loads if we're not going G&N. And you'll never get one, by the way, if we don't.
Something that always confused me, it did on the other SIM, was your Verb 76. Now, I made a point earlier. When you sent out a Verb 76, like on the 2-1, where we might SEP at Carnarvon or earlier, would you flag it as being good post-SEP, normal SEP, or something like it in the remarks section?
The only one you're going to get, it's only 76 that you're going to get, is the one that includes the normal SEP burn. If they come off that early like they did today, we can't control that.
I know, that's right. Okay.
But every time, that's what I said, every time you get, the only nav vector you get at Carnarvon, and I think Guidance agrees with me on this one too, is the one with the SEP maneuver in it. Okay? And if they've already SEP'd, of course it's okay, but if you get one, it's with a SEP maneuver in it.
Okay, now if we run into a case like we had today, like Chris said, it's close enough, we'll go with it, right?
Yeah, we wouldn't have stopped you. Look, what you did was done right, because we would have never sent it if we didn't think we were coming in G&N, babe.
Okay, I just want to make sure that what he said was okay. Is the premise is close enough to go ahead and use it, regardless of the SEP?
Yeah, but the SEP is usually based on nominal time.
Gotcha.
Okay, it will be the right number. It will be the only right thing that you got out there.
Okay, then if we get in that case, then we will update that one.
That's affirmative.
All right.
Go ahead, John. Just for our education. A lot of questions.
No, that's okay, babe.
Now, John, one other question. On this RCS.
But all I'm saying is that the maneuver includes the normal SEP maneuver, and if they do it at a different time, then we can't help that, but it's still better than what they got on board.
Okay, good.
Okay, John, one other question. I got a pad, okay, for this 2-1.
Mm-hmm.
Okay. Would there have been a deorbit load through 2-1?
Not in this case.
Okay, I was sitting here waiting for a deorbit load also.
Say again?
I was waiting for a deorbit load.
Yeah, but on this time, all you'd have to do is read in the top half of that pad, and he could do it with that only.
Okay.
Okay.
Steve?
Yeah.
This Will?
Yeah, Will.
I think in most cases like this, what we ought to do is mark it down there in the remarks of the pad, that it be SCS control or RCS burn or something like this, so that you know it's not G&N. And so that if it's not G&N, there won't be any target data with the pad.
Okay.
Question for you, Will or John. In any case where we do an RCS deorbit, will you send a deorbit target load to us? I thought you'd do this.
Yes, we will. I believe that we would in some cases if we have like a G&N entry, a G&N controlled entry, okay? Like we know that the G&N's working, and we may want to do a realignment or something of this nature. Like, let's say for some reason, we had a completely out-of-plane alignment, and then that was the only thing wrong with the G&N as far as it being able to monitor an entry after RCS. Let's say we knew we had an SPS failure, but the damn platform was completely out of plane. So we'd send the AGC a target load, let it do a maneuver computation, and do a preferred alignment. Okay?
Okay, well, I guess we'll have to get together again on further briefings on this. I'm confused, and I guess it'd be best to get together in a conference room and go over it.
Right, I agree.
Okay.
Well, look, I guess what we say, we got such a complicated system, babe,
You're right.
That if we a lot of these cases come up here, we're going to just have to tell you what we're going to do because we don't ever do the same thing twice, and we can't write a standard procedure. I don't think at this time to find out what we do.
Okay, John.
If we're gonna, I'd say in general that we will send you a deorbit load with a nav load and a rest mat if we have time. Okay, and then when time starts getting to us, we start dropping off things. Okay.
Okay.
Let me ask you guys something. Do y'all have Gauss 2 at the site?
Yes, we do.
Okay, I think in most contingency cases that we could use Gauss 2 to come to you and explain what we're trying to do.
I think 30 seconds or a minute spent doing that would help a whole lot.
Okay, maybe I'll start doing that.
I tell you what you do it like you did in Germany and Mercury. If you don't understand what we're doing, come to the rectifier officer, guidance officer, and tell us, and get the AFD off the loop. And if you negative reporting.
Roger.
Okay? Nothing new, huh, gentlemen?
I guess I don't understand what I'm doing out here. I'm going to be calling you.
Okay. Good, Ed. If you understand what we're doing, don't bug us, because we got enough here to do to pile us right up on the floor. But if you but if you don't understand, for God's sakes, come at us, yeah?
Roger.
We could have helped you on that one, babe, because if you'd asked me, I'd tell you update it.
Well, that's what I did.
Okay. It snowed me, too. That whole thing got me.
We'll all...
I guess what happens, Stu, is so many things failing there. By the time that we got caught up with the thing, too, because we get locked up here, we didn't know that the GNN was in such a position that you couldn't use I mean, the power was in such a position you couldn't use it.
I don't think it ever was, John. That's the point.
We got reported that it was good, John. The GNN is good, but was the power good enough? That's the point. So you have to have electrons to run it.
Yeah. But you got fuel cells on it. Fuel cells will run it.
Yeah, they were good, John.
Talking about post-SEP, John, is that right?
I don't know why he declared it no-go.
Well, that's above me. I don't know either.
Okay, we'll have to talk that one over. Okay?
All right.
Maybe he did it because of time required.
Yeah.
Adios.
All right.
Bye.
Probably was FSCT. Houston STC, Black 3. Houston STC, Black 3.